Question 3 have the values again. Heat energy supplied to the statue 6.3 times 10 to the 5th joules. Initial temperature of statue 16 degrees Celsius. Final temperature of statue 95 degrees Celsius. So that gives us a temperature change of 79 degrees Celsius. The specific heat capacity of the material of the statue is 3,500 joules per kilogram per degree Celsius. And the mass of the statue, that's what we want to find out. So we write our heat equation again. EH is equal to mc delta theta. Substitute for m in the equation. M is equal to EH over c times delta theta. So we have 6.3 times 10 to the 5th joules divided by 3,500 joules per kilogram per degree Celsius multiplied by 79 degrees Celsius. And that gives us an answer of 2.3 kilograms. Round off to two significant figures, because if you notice, two significant figures is the least number of significant figures used in the calculation, and your answer cannot be more precise than the least precise value that you use. So it's 2.3, you round off to two significant figures. Question 4. Mass of water is 120 grams. Again, we convert to kilograms, that's 0.12 kilograms. Heat energy supplied to the water is 2.4 times 10 to the 4th power in joules. Initial temperature of the water 19 degrees Celsius. We don't know the final temperature. However, the heat capacity is 4,200 joules per kilogram per degree Celsius. So again, we apply our heat equation. EH is equal to mc delta theta. We are solving now for delta theta, and that would be equal to EH over m times c. So we have 2.4 times 10 to the 4th joules divided by 0.12 kilogram multiplied by 4,200 joules per kilogram per degree Celsius. That gives us a temperature change of 48 degrees Celsius. This is not the answer, however. That's just a temperature change. Now we know that the temperature change is equal to theta 2 minus theta 1. And the temperature change will just work out to be 48 degrees Celsius. And theta 1 is 19 degrees Celsius. So 48 is equal to theta 2 minus 19. And therefore theta 2 must be equal to 48 plus 19. That's 67 degrees Celsius.